Hello, my friends of Qatari Labs. Welcome to this webinar. This webinar is for land cover classification with machine learning, and in this case, we are working with naive-based algorithm. Okay, and the process that we are going to do is similar if you are using naive-based, if you are using a multi-layer perceptron, regression of multi-layer perceptron, and so on. I mean, if you search into those options of the Scikit Learn library, you will find that the process is pretty similar. Okay, so in this case, we are going to work with the naive base, yeah, because it works faster than if you do it with multi-layer percentage. Okay, just to tell you some things about this webinar. First of all, you can always ask for more time or that I repeat. You can always do that through the chat. If you have any questions, yeah, if you have any questions, you just can open your mic and ask your question, okay? Or if you cannot open your mic, you can do it through the chat as well, okay? Along the webinar, I will be giving I will give some answers like say type 1, type 2, type 3 because this is important because I can assure that you are actually following the steps. So don't be lazy and type the number if you were able to follow these to follow the steps. Okay. The recorded version of the webinar just today I finished configuring the Patreon of Qatari Labs. Qatari Labs. So yeah, so all the recorded videos of this and every other webinar will be through the subscription in our Patreon. So you just pay subscription, pay the once, and so as long as we are going to develop more webinars, all of them will be stored there. So if you want to support our research and if you like our blog and the things that we do, yes, you can also support us by subscribing to our Patreon. Okay, great, great. So are we ready to start? If we are ready to start, please type 2. Okay, great. So let's start here. Let's start our Anaconda prompt. And here from our Anaconda prompt, we type CD document. That's why you have to place that on document. And then we type here. And then here we see webinar of land cover classification with naive Bayes and Python. So say CD webinar of land cover classification with naive Bayes and Python. And here please type Jupyter Lab. You were able, actually this will launch, okay, we have to go back. Okay, we have to kill the kernel. Why we have to kill the kernel? Because we forget something. Okay, and what we have for, in order to kill the kernel, we just type Control C many times, and then we kill the kernel. Okay, if you are here with me, just here with me, I mean, if by any chance you have killed your kernel, or you haven't not started yet, but if you are here with me, please type 3. In order to kill the kernel, just type Control C many times. Or I can do it. I mean, if you want to start from the beginning, it's just so easy. Just open again Anaconda prompt because we actually haven't done that much. Here you see the documents, and then here see the webinar of land cover classification. And as you have read on the instructions here, okay, this classification will cover categories, okay, but what it says is create an environment, okay, create an environment, important, okay, you will need a Conda environment with the geospatial tools for the webinar. If, uh, where are the input files are here, okay, grade values, and the password is cataloged with capital H. Okay, please type 4 if you have uh, if you have installed the environment. Okay, if you have installed the environment, please type 4. If you did have not installed the Conda environment, please type no. Okay, normal Navila say can it be used in color? Actually, I don't know. I mean, I don't know if you can use that in color. No, I don't use that. Okay, who else do not have the environment? Okay, who else? Please type because I want to measure how many of you do not have the environment. Okay, please type just 2. Wow. Okay. Okay. Okay, what I will tell you for the people that were not, please open this link and then you don't have to type that much. You can follow me, okay, you can follow me and then you can, we have a kind of a background script where you can configure. Actually, I cannot wait that you create environment. Or you can follow the video and then later on you can do it by yourself. Okay, great. Okay. Great. So here we type Conda and list. Okay. And here I have the environment Geo Jira Hatari. In the case of the tutorial is Geo Hatari Labs, it's the same. So say Conda activate Geo Jira Hatari. Okay? Conda activate Geo Jira Hatari. So if you have activated your environment, please type 5. If you have activated your environment, please type 5. Okay, great. And then here we are going to type with environment Jupyter Notebook. Okay. No, but first at the beginning, or maybe you just can follow me. Okay. If you want to clear everything in Windows, it's CLS. Okay, and then we type pip install conda list. Okay, so in order to do this, we need some package, and then we have to be sure that we have those packages. Which are those packages that are installed in the environment? For example, we need the GDAL, so we have to look if the GDAL is installed. Okay. For example, well, the pandas is not required for this, but it's installed as well. PyPro is another library that is also needed. PyPro. PyPro is also needed. For example, Rasterio is also needed. So what is Rasterio here? And this is Rasterio. Rasterio is here. Okay, so we have all the package, and the package are installed on the environment. So yeah, if you follow the steps, actually you have installed all these packages, and those are the ones that we are going to use. Okay, and then type Jupyter Lab. If you now if you are with the environment and then you have your Jupyter Lab, please type 6. If you are here, please type 6. Okay, and then we are going to see what we have here. First, we have on data, we have the classification, okay, and we can open that through QGIS, okay, and then you can open that to any other, but let's see what we have, because those are TIFF files, and actually you cannot open TIFF files nothing will come, nothing will appear if you open that from Jupyter. Okay, so let's see. If you have any questions, you can open your Meet, and then you can ask your questions, or you can drop your questions through the chat. This webinar is intended for people that actually have some experience with Python. And then later on I will do some research like about the Python level. I will do some research about the time schedule, like if you prefer this schedule or 6 p.m. Amsterdam time, and so on. So here we are going to, on the navigator, um, on documents, on the webinar, on data, here we have on the classification, we have the land cover classification V2. And the land cover classification V2, yeah, is a land cover that I can go to properties. This is actually not, I'm not going to wait for, okay. Okay, this is a classification where we have the we have as well the raster on the river image. This is not a QES class, really sorry about that. On properties, QES you can, I mean, if you are not fluent with QES, you can follow me to that. We are going to spend much time. Okay, so what we have here is a land cover classification of 10 that classifies the river. We have a land cover classification of 20 that actually classifies the river beaches, and then we have a land cover of 30 that classifies the eroded rainforest. I mean, like deforested rainforest. And then we have the land cover 40 that actually classify the the dense rainforest. Okay, if you have understood this, please type if you have understood this, please type 7. And what is ground truth? Ground truth. Okay, great. So this is, I mean, this is the raster that we are going to classify, but this is the classification raster. So this procedure actually works with a classification raster that has the category, and then we are going to classify for another part of the image. Okay, and in this case, we are going to do it over where we do that over the bands red, green, and blue, because this is a panchromatic image. Okay, but we are preparing a diploma in Python for water resources and geoscience, and this diploma for Python in water resources has a module of geospatial Python, and on the last class we do this exercise, but for the 8 bands of a Landsat 8, for all the bands of a Landsat 8 image. Okay, so this is kind of more robust and actually do not work with the visible spectrum, but will rather with all the bands that deal the that is a modification, that is a kind of a complexization of this. Okay, the diploma for Python for water resources will be published maybe in 10 days, okay, because actually we have to do a lot of research to have the material, and then we cannot publish until we have all the material. Maybe the diploma will be launched in 2 months. Okay, great, and I hope that you can join us in the diploma. Okay, so let's see. So we are going to classify from this classification raster to this. Okay, actually we are going just to do a small part. Okay, but because it takes time, so if you do it that for the whole image, maybe I haven't done it, but maybe it will take time that actually won't be needed. I mean that won't be used in this that won't be so therapeutic. I mean everybody will be waiting for this. Okay. So let's start with our coding. Okay. So here we go to what has happened here. Okay, sorry. Okay. I don't know what happened. Somehow. Okay. So let's go here to notebook and let's create a new notebook. Here inside notebook, please create a new notebook that will be called right click part 1. If you have done so, please type 1. If you have done so, please type 1. Okay, who else? Yes. Okay, great. Let's see, we have 30 people here, 30 people. Okay. So let's start typing because first we are going to import rasterio, and then say from rasterio plot import show, because show is really an utility of rasterio that allows you to plot geospatial rasters. Okay. Then we are going to open the classification raster. So I say class raster is equal to rasterio.open data class land clover classified into .div, and then we can show the class raster. Okay. Great. If you are here with me, please type. If you are here with me, please type 3. There is a question that says that if we can download land cover from the Copernicus land service, actually I don't know. If you are here with me, please type 3. Okay. I will. Is this a geospatial representation of the raster, or this is a raw color representation of the raster? Please type on the chat. If this is a spatial representation of the raster, or if this is a raw color representation, matrix representation of the raster. Please type your option in the chat. No, this is a spatial because these are coordinates, okay? Yeah, those are coordinates. Those are coordinates, okay? And because you have the other, you can plot a raster with matplotlib pyplot with the in show, but this will give you a representation of the raster but as a matrix. Okay, so this show is a utility from rasterio that can allow you to represent your partial raster. Okay, I tell you that because when you do your when you do your research, you forget about what exactly this does and what exactly matplotlib does. Okay, well, so let's open the class band because this is a single band, single. There is only one band, so this is class raster grade 1. And rasterio we actually do not start the band from 0, we start from 1, and then we can show the class band the values. Okay, and then here we see 40, 40, 40, 40, 40 because we are here. Okay, so where everything is 40, yeah, and then here in this part is 40. Okay, so if we are in the lower part, we should see, for example, if we are in the lowest part and -5, we should have seen 10 because 10 is the river. Okay, so we are actually seeing this. Okay, so this is 40, 40, 40, and this is 40, 40, and 10. Okay, if you are here, please type 4. If you are here, please type 4. Actually, for anybody that is stuck in something, so I will give you my WhatsApp number, so you can send me a screenshot of your, you can send me a screenshot of your problem. If I can help you on the spot, I can help you on the spot. But if it's not, maybe there is still a chance that I can help you. Okay, so this is the raster band as a matrix. Okay, so we have to capture the number of rows and the number of columns. So say n row n col is equal to class band shape, and then we can print n row n column. Okay, so we have 42 rows and 56 columns. Okay, and then we are going to show. Then we are going to show something that is also an utility from Rasterio, that is so we are going to get the coordinates. Okay, so let's see, and this is because this is really important for the tutorial, and then I wanted that this is okay. If you are here with me, please type 5. We are on Rasterio. Okay, we can capture the coordinates of a row and a column because the row and column is just one cell on a grid, but we want to capture the center. Okay, so we can do that with instance of the raster. So let's say for row in range, and row range, then row 3 for call range for the first 3 rows, for the first three columns, and say class RST, that is our raster object xy row column. Okay, so this gave us the position, the row and column. Okay, and let's see class two. So here we have for the first row, yeah, those have the same y, and those are the second, and these are the third, and this is the first, the second, and the third, first, the second, and the third, first, the second, and the third column. Okay, if you are here with me, please type 6. If you are here with me, please type 6. So here, this is a utility of Rasterion, that is it's an instance of Rasterion with the Rasterio object that can give you for a specific row and column the coordinates of the center. Okay? Normal say, what do I want to set the pixel value for the lat and long? What if you want to search for the pixel value of lat and long? Uh, yeah, there is a yeah, there is an instance of that, and I will explain you later because we use that as well. Okay, so this is the class raster, and then we are going to open our image raster. Okay, yeah, and then is where we insert the pixel value of row, the, the row on code. Okay, there is when we insert a lat and long, and then we extract the pixel value. Okay, so let's say image raster. This is the panchromatic image. Is equal to rasterio dot open data raster primer image 2, and then image band is equal to image rst dot read. Great. So this is an image band. So actually, this is the red band of this. Okay, this is the red band of this. The red band, only the red band, because we are then later on we are going to work with three bands. Okay, and then say, okay, I want to capture the the pixel value for a specified lat long. Okay, of this band. Okay, so it's row call is equal to image raster and the index. So index is the opposite of xy, because in xy you insert the you insert the row and column to get the position, and with index you insert the lat and long to get the row and column. Okay, minus 73.16275 minus 3.9172. Then value image then row. Okay, so with that, we get the image band that in this case corresponds to the red band, and then we get that for this specific coordinate. Okay, if you have here with me, please type 1. Please type 7. Okay, now we have 33 people. 33 divided by 170, so we are around, yeah, 20% of the people that have signed up for the webinar are actually. Okay, great. So, any questions? Let me know. If you want, open your mic. Okay, so now let's work with the different bands. So red band, is equal to image path with one with is equal to image raster two do then is equal to image path column. And then we create a list of the bands. Okay, this comes from the object-oriented programming because actually everything is an object, and even the red band that is an instance of raster can be an object of a list. Okay, great, great, great. So here we have created a list of the three bands. Okay, but those three bands are actually not arrays. Those are, well, if I is array, but this is an instance of raster. Okay, great. So if you are here with me, please type 8. And then in order to do something more miscellaneous, I would ask that you can tell me from which city you are connecting. Okay, Mexico City, San Salvador, Guatemala, Buenos Aires, Chula Vista, Hamburg, Manchester, Bonn. Yeah, I did a German course in Bonn. Mexico, from Seoul, New Delhi, Brussels. Okay, great. So for other people, South Africa, yeah, really. And Arequipa. Okay, who else? Please give the coordinates of it. Yeah, around the globe. Around the globe. Okay, for other people, maybe for you is too early, too late, but thank you for connecting. Okay, great. So let's, okay, so we are going to create a function that returns a raster value because we, since we are going to do a research over many pixels, we need a function. I'm going to say there raster value that will use the image raster. Why the image raster? Because the image raster is the one that has the index. Okay. Then the image band, because this is the array, and the x and y, okay, and then say row column image raster index of x and y band value image band row column. So from the image raster you get a row column, and then from the image band you get the value, okay, and then you return that value. You return that value. Bangalore, Manila, Morocco. There is a question: can I convert ASCII row column to TIFF? I will check Narayan as how to convert ASCII row class values to TIFF to further algebra. Why? Yeah, you can do that with Rosterian. I think that we have done a tutorial on that. But I will tell you that coming to your question that you use a lot of proprietary software, so give a chance to open source software. Okay? QGIS box. Not even QGIS, the skills of QGIS, open source. Yeah, and you can do it with Jedal and as well with the Python package of Jedal as well. And Raster as well can do that. Okay, great. So here we okay, so here for example we are going to do an example of our raster value of image raster of blue band, of these coordinates, okay, will be 45. But if you do it for the red band, it will be 15 because it has to be the same of this because it is the same coordinate, okay? Yes. Okay, they told me that I have to do it without me. Okay, interesting. I didn't know that that was. Okay, thank you, Norma. Okay, let's continue. So let's see, and then what we are going to do next is that we are going to have, okay, we are going to have uh, for every pixel in our raster classification, okay, for every pixel in our raster class, we are going to have the values of red, green, and blue. Okay, that's what we are going to have. And since this is a kind of complex or maybe it took some time, we are going to import the sys in order to have a message from the record or a log of the advanced of the function. Okay, class is okay, let's see. For row in range of in row, okay, for call in range in call, okay, and then say sys, and this is just the std out right, and then say this is to prevent the but for some reason you have to do it with working with row call. Okay. And this comes with a tuple. Okay, this is just to show you the advanced how we are with the function. So sometimes it takes a long time and then you realize that it was not doing well, so that's why. And then we get a partial line, an object that is an empty line that is going to store the image values for the, I mean, it will store the value for red, for the value for the red, the green, and the blue band for every pixel of the classification raster, of the class raster. Xy is equal to class, because we are working and we are iterating over the class raster. For then, values equal to raster value of image raster band xy. Okay, the partial it will store this will store the values for all the bands. I mean, for every band, because the band list is a list that stores all the bands that we have. So partial, and then finally we append the class value. Okay, and then just to notice these are capital L. Okay, this is a capital L. I used to work like this because it's more practical instead of having everything in lowercase or like SMS underscore. So yes, and then okay, so it's much faster, but okay, so okay, what we did is we are going to work with the class raster, and for every pixel on the class raster, we are going to get the values of the red, green, and blue band. Okay, even that the resolution is not the same, but well, we are close to where we are going to capture that. Okay, if your raster classification is of lower resolution, you can actually have more points, but more points would mean that the code will also get slower. Okay, so and finally, what you got is the class list, that is a list of of lists where you have the red, green, and blue, and as well the classification value. Okay, is that right, Mohammed? And if you are here with me, please type. Okay, great. So, great. So the next step is that we are going to store this. Okay, we are going to store this because why we are going to store this? Because we need that for the next part of our class. Okay, we can do this code in just one notebook. However, however, mm, sometimes you get lost, or sometimes not even that. Sometimes you get lost. But it's better that you have partial results, because otherwise, uh, when you want to see what went wrong with your own case, and then you can split that easily, that it went wrong, or the first part of the second part. I hope that you can understand. Okay, so here we are going to say import numpy as np, and then we do our list of lists will be our np array of class list. Okay, so this is the same, but yes, it's a numpy array. And then since we are np save, oh, data txt class class array, and you don't have to put extension. Why? Because actually it will bring you the class array dot mpy. Okay, class array. Great. Okay, one question. Why we have stored our numpy array as an mpy file, and why we haven't stored that as a text file? Please give me your answers to the chat. Okay, and then you can also tell me which is your Python level. I mean, if you are beginner with Python, if you have some experience with Python, if you are excellent with Python at this little level, or like if you, okay, you can tell me to the chat as well. Okay, two questions. Can you tell me which could be a right reason why I have stored that as the array as an MPY rather than as a text file? And then please tell me if you are a beginner intermediate. Okay. Okay, they told me that the MPY is not too heavy as a text file. Yeah, but even that, there we are not talking about many values. Okay? There are people that are, a lot of people are beginners, some of them are intermediate. Okay, so I asked that because then later on at the end you would tell me that if you were able to understand most of the topics that we have covered in this webinar. Okay, because yeah, if you are a beginner and then we provide you applied stuff, then we have to ask. I mean, we don't expect that you have understand that everything. I mean, if you have done so, really congratulations to you. But if you have understood the core of what we are doing, because I mean, if you want to apply this for your own research, yeah, by sure you have to review this code. Okay. Okay, great. Okay, why we have said that as why we have said that as an MP, as an MPY, as a class array, as an MPY, is because if we open that in the other notebook, okay, if we open that, actually it will open as an numpy array. It will open directly as an numpy array. Why? If we open that as a text file, we have to read the text file and then we have to translate that to a numpy array. Okay, so that is why, I mean, yeah, that's one main reason. A reason for me is say I want to store numpy array. I don't want to store values. I want to store the array. So that is why I have this. But okay, if you are here with me, please type 7. Okay. So we are going to create a notebook, another notebook that will be called part 2. Part, okay. So on part 2, we are here is where we are going to do the night base. Import numpy as np, import scalar night values ah, from 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 scalar night value import voucher np of scalar model selection import frame text, because we have, I mean, Why we import the test train? Because we have to measure how well we have done our classification. There are ways that we can measure that. Okay, great. So just read this. Maybe for you, you don't have the Scikit Learn installed, so you start pick install Scikit Learn. If you don't have that installed on the, okay, but in my case I have already installed it. Okay, but if you got something that is scale learn is not installed, you have to run this once. Okay, okay. If you are here with me, please type 8. If you are here with me, please type. Okay, great. So let's continue. Well, we have stored an empty white, then we have to open that. Okay, because the main reason was to store the NumPy array, so empty load data txt. Let's see, class, and I use auto-completion because actually it would recognize the file. Let's say class array. And all of this stuff was just to store and load our array. Okay, if you are here with me, please type 9. If you have any problem, let me know. X is equal to class array. Oh, okay, the class array is the last row, okay, and this is the last row. This is a slicing of the numpy for to get the last row, the last row. No, the class array the class array are the first 3 columns. The first, sorry, these are the band values, and this is the classification value. The band values are the first 3 columns, okay. So, and for example, here I can give you the first 2 rows of these 3 columns, okay? And this is the X and the Y, so the value will be the last column, okay? This is the X for our knife base values that are the band values, and then in the other side we are going to have the classification value, okay? Any questions? Let me know. Okay. To save the rate is great. If you are here with me, please type 1. And then the y is in lowercase, is class array. And then the first 2 values will be 40 and 40. And then we split our X train and our X test. Okay, why? Because we have to measure how well we have, uh, how well our naive Bayes algorithm is classifying the soil cover. Okay, that is another dimension, because uh, then is when you are going to measure how well the machine learning algorithms work as well. Okay, and this has a lot of stuff inside. because there are several algorithms, and the performance on that is, I mean, whether you read a lot of literature or you just uh, play a lot with the algorithms and then you can see how it works. Okay? It's a whole bunch random state. Okay, and then I split that in two lines, but actually here you can do that in just one line. Okay, so we split our x is always in capital and y is always in lowercase. Okay, great. If you are here with me, please type. Okay? If you are here with me, please type. Okay, see there is equal to Gaussian naive Bayes. This is how it's called the algorithms in Scikit Learn. Maybe in another library will be called different. Extreme. Widen. Okay, so here we create the is just one. Okay, so we create the, and then we are going to predict our values. Predict equal to CLF predict x test. Okay, so let's have a predicted values. Okay, so those, I mean, the x test is a red, green, and blue. Yeah, that is was not used on the train path, and the J predict are the predicted values, and then we have the J test, and then we are going to compare. Those are the values that these are the results that we have that will be compared to. Okay, so kind of complex. I don't know if it's complex for you. I mean, uh, unfortunately, we cannot go further on the theory about how this is made and so on. But if you somehow follow me, please type I follow you. Or maybe if it's too complex for you, just type it is too complex for me. I mean, don't worry. Yeah, okay. Yeah, there is a stat quest in YouTube. I will recommend you this tutorial and this channel that actually it was the one that I used. They explain very well what is a naive-Bayes algorithm and so on. So you can, I mean, this is the fastest way. Uh, this is the fastest way to understand what is exactly after naive-Bayes. Okay. Oh, great, great. That is amazing. Okay, so let's see. Okay, so we are going to compare how well our naive Bayes algorithm uh, has classified how well it has done. Okay, so here, let's say import matplotlib plot as plt. P is equal to plt figure of the size of 6. Plt starter with this. Okay, and this is a scatter point that shows you of all the values, for example, all the values classified by 10, there are some that were classified because this is the observed values. The predicted values, some were classified as 30. Okay? Of values classified by 20, some were classified as 20 and some were classified as 10 and a little bit as 30. Okay, of the values classified as 30, some of them were classified as 40 and some of them were classified as 20 and maybe one were classified as 10. Okay, and then the value classified as 40, well, some were classified as 10. Okay, so this is kind of a correlation. This is a kind of a test that tells you how well I mean, as long as you don't have any value outside this diagonal, your machine learning algorithm was perfect. Okay? If you are here with me with that one. Okay, however, there are better ways to do this. Okay, there are better ways to do that. Okay, so there are more tools for this. Okay, because actually we are just working with we are just working with a graphic, but there is a tool from Scikit Learn Matrix from scalar.matrix import confusion matrix. Confusion matrix. Conf matrix is equal to confusion matrix y test y credit. Okay, so this is a confusion matrix, and this as well relies on the diagonal. This is 10, 20, 30, and 40. Okay, and they say, okay, of all the values of value 1, 238 will classify as 10. 10 will classify as 20, and 2 will classify as 10. Okay, so well, I feel that for value 1 is strong. Value 2 for 20, yeah, most of them were rightly approaches well, but for value 30, our performance is not that great. Okay, even that the majority of the values classified as 30, not even the majority, is the, the bigger value were classified as 30, but there are other classified as 10. Uh, okay, I think that even that if we sum the values that were not classified as 30 are bigger than the values classified as 30. And for 4, yeah, the correlation is well as well. Okay, so if you follow me, well, Jack said that looks good. Thank you. And okay, if you are following me, please type two. Please type. Okay, and well, we can improve our. If you don't have Seaborn installed, you can install it. Please install Seaborn. Seaborn. Okay, most probably you don't have it, so say import Seaborn as SMS sms.set thing. So thing is equal to usb.user.set. Okay, and this is well, it will give me that I do already have Seaborn installed. Okay, and then later on it will provide me the classification matrix. Okay, so I will comment this. Okay, and this is another visualization of the this is another visualization of the confusion matrix. Okay, that is more graphical. Yeah, it's another way. I mean, if you are doing a paper, you insert this. That has to be okay. Okay, if you are here with me, please type 3. Okay, so well, we have what we know is that our algorithm can classify well number 10 and number 20. On number 30, it's kind of poor, and number 40 is a great classification. Okay, so that is why we are going to do. Okay, so we are going to classify, and maybe on number 30, our results won't be as good. Okay, just 5 people there. Those 3. Who else? Okay. About the next webinar that we are going to have, it will be of assessing flooding areas with your pandas. Okay, spatial analysis. We apply spatial analysis with the pandas of inundated areas. Okay, the date will be actually I don't know, but it will be published over our social networks. Okay, so if you have any topic that we might consider with Python, please write that on the chat, and maybe you can inspire for covering topics. Okay. Okay, so great. So now what we are going to do is we are going to create, well, we are going to do the classification. Okay, so far we have run the neural network, okay, but we haven't classified it. So now we are going to classify, because this analysis is only on the classification, but we are going to classify we are going to classify another section of the raster. So import rasterio, the resolution will be 0.0005, this is in degrees, and then you can select any, this is just for the performance in this webinar, but you can play around with that. This is the XY, this is the lower left corner of our raster, but this is the centroid of the lower left cell. Mm-hmm. X L, Y L. This is the lower left. Okay, so we have defined it, and this will be the resolution, this will be the size of our raster, and then you can select any size that you want. I mean, this is independent of that. Okay, so what I have seen that nobody is interested in another other topics. Well, I mean, you have my email, so you can go at Lab, so you can drop your comments when you have it and so on, because yeah, sometimes we got inspired and put our topics, but sometimes like well, we are not so inspired. So okay, so let's define the affine. What is the affine? Is the transformation matrix, the one that transforms the row and columns to geographical coordinates. Okay, and this actually comes from this comes from Gidal. Okay, and the well, so this is the transform. You can review more on that because this is actually a matrix where here there is a third row that is 0, 0, and 1. Okay, so whenever you insert a row and column, it will give you x and y. Mhm. Okay, and then we are going to well, since we are going to create a raster, since we are going to create a raster, we have this raster needs a system of reference. So from rasterio.crs, import CRS and capital, raster CRS is equal to CRS from ESP. So this is the CRS as an object, W26, WES84, raster CRS. Okay, great. So this is our system of reference. Okay, and now we are going to say we are going to create our raster. We are going to create our raster object, rasterio.open, and then here we are going to create it, data raster. This will be river image 3.tif. Okay, because there is the river image 2, but in our case it will be river image 3. Okay, then okay. And no, this is the river image 2 because we are going to open again. We are going to open again the raster bands, but if we are lazy and then we do that as well, we did this is this cell in the other in part 1, so we just copy and paste, yeah, because we need this. Okay, so and then we run. Okay, in this case is image. If you are here with me, please type. If you are here with me, please type. Oh, okay. We are going to bring some code of part 1, okay, because those codes actually do the same. I mean, okay. For example, we are going to take these raster values and then we are going to insert our raster value. then say here import raster, and then we create a clear and empty array. Okay, great. And then we are going to bring as well the late this one. Okay, we are going to bring this one. So okay, we are going to bring class list and page row column talking with version line, and here we are going to comment this. We are going to comment this. Say x is equal to x0 plus all times res y x0 plus row of x. Because we are working from the bottom. Okay, these are the and in this case this actually, I mean, we are working over the matrix but from the lower right corner. Okay, so the and then from that we are getting the values, okay, the values of the different rasters, and then we append that value. Okay, and then we just comment this and this and say jcredit clf credit empty array. Okay, this is the whole, this is the whole code. Okay, and then I will explain what we have done that once after you have typed 5. And then Jack says, should it be, this is what is here. Thank you. Is y0 and x0. Okay, so if you are here with me, please type 5, and then I will explain what I have. And I will explain what I have. Okay, okay, what we have done. Okay, what we have done. Let's get the main. Okay, yep. Okay. we have a array, and this array has several rows and columns. Okay. However, in this case, we are not working as a normal matrix, because a normal matrix starts from this cell. We are actually starting from this cell. Yeah, this is x0, y0. Okay, and in this case, the y increases this, no, the x increases in this direction, and the y increases in this direction. Okay, for every cell, okay, for every cell, we got, okay, for every cell, we have the row and column, that this is translated in the xy, and this actually gets the red value, the green value, and the blue value. Okay, and these predict with the naive Bayes and provide you the classification. This is what it does. Beautiful, isn't that? Okay, this is what it does. I mean, you can drink your coffee, tea, tequila, rum, whatever, and then you can understand. But this is what is doing. Is that clear? Please type 6 if it's not clear. Uh, is this clear? Please type it's clear, or if you want more explanation. Please type it is clear, or if you want. Okay, great. So we have created with Rasterio a raster. We can Rasterio create a raster object. Okay, and in this raster object we have encalls and then rows, encalls and then rows. Okay, and then we have the x0, y0. Okay, but in this case we are not going to work like a normal matrix where the rows increment is this way. We can increment our columns in this way and our rows in this way. This is up to us. Okay. Okay. So what it does for a normal cell, it you have the row and column, and from that it gets the x and y of the centroid, and from that, from the function raster value, you get the value of RGB, because this is actually on the list, because on the band list. Okay, and from these values, the naive Bayes will predict the land cover classification, and this will store, that will store here, that will store here. Mhm. So, and then this is where you are going to have an inverted, matrix, because actually, but this you don't have to worry about, because when you export that to a geospatial raster, it will invert again. Okay, this is kind of, well, don't worry about that, because, okay, so what I will tell you, okay, I will run this. Actually takes a little bit more time. Okay, and then you have here the class array. okay, and then you can show here the in show plus array, okay, but this is inverted since your rows, for, why this is inverted? Because here the rows increases with decreases uh, or increases in the negative sense of the y, but in your algorithm those increases in the right side of the y. Okay, so that is why what you have here it has to be inverted in the direction of y, but don't worry about that. Why? Because when we export that as geotiff, it will do the, it will transform that. You will see that inter raster is equal to raster dot open, okay, data plus predicted land cover 2, because we are going to go land cover 2, comma, is a right, so we are creating the okay, so it will be adjective, so it can be image, so height is equal to row, width is equal to point, count is equal to just one band, big type is equal to maybe a slot of 32, CRS is equal to raster CRS, and transform is equal to transform, and then we can post this. Okay, so with that we have created the objects and say inter, and then we write our raster file, and then we close. Okay, so we run this. Okay. I will comment this because I want that you can see the most of the code, and then I can run. Okay, I have run it, and that has created here on data class the predicted land cover 2.p. Okay. Yeah. Alberto says if the raster has more bands, they can be added, modified. Yes. Yep. Yeah. Yeah. What you have to do if your run has more bands, your raster band will be higher, will be much bigger. Okay. Great. So, how are you have finished? Please type 9. If you have finished, please type. And then they say, can we use the methodology in Python? Yeah, sure. I mean, whatever you can just create a, yes, why not? I mean, not for me, but Okay, so let's go here and let's open on class. We have the predicted land cover 2, that is the file that we have opened. And here on layers, we can go to properties, symbology, unique values, classify, and those are the same colors. And we can give some transparency as well. And then here have this. Okay, if you are here with me, please type 1. Okay, great. Uh, Great. So let's see and let's analyze. Okay, on the river, we see that the river, that is value 10, here in this part, many values of were classified as eroded land. Okay, well, this comes from the bands. Okay, the river beaches were rightly classified. I mean, there is a good fit on the whatever is the river beaches. Okay, the intense vegetation is as well classified. Okay, and the erode the on the here, for example, this part of is, yeah, it's also well classified. The forested rainforest. Okay, so yeah, the classification is great. Okay, however, we have to keep working on this difference in between the number 30. Okay, that where there is a confusion on the deforested rainforest and the river. Okay. Did we run the model only for a subset of the matrix? Yes. Yeah, we have run the model not for the whole, just for the subset, because it will take longer if we run it for the whole image. Okay. Great. So that will be the end of this tutorial. I don't know if you have any questions so far. If you don't have any questions, okay, I will strongly recommend that you type goodbye in your own language. I mean, or in your dialect or whatever. And if you have any questions, you can let me know. And just to tell you that the video will be available uh, through the video will be available through the Patreon channel, okay, and as well all the videos that we are going to tell, and then we hope that we can see you in coming webinars. But if there is a question, I can answer that. Classification of different crops, yeah, it's possible, yeah, and it can be in another, yeah, but this, I mean, Albertino, I mean, if you just put this and then if you work with, I mean, it's actually not that different. to classify among nodes. It's just a tweak to this code. Okay. Who else? If, but if you have a certain data set, you can send me that data set and then I can see. Okay. Okay, your data set, if you have books, actually, well, there can be some books, but I strongly recommend that you follow, for example, the TabQuest YouTube channel where they talk about how the different machine learning work and the documentation of the package. And then Abhishek asks to add header to ASCII. Well, this might be too specific. And then Balayak, if you can do object basic, yes. When on the course of uh, crop recognition with Python, yeah, we do that. Okay, so these all our courses are recorded and available in our e-learning platform. And what they ask for, look for a classification, what is AULC, well, we don't know which is algorithm. Okay, so please remember that